Okay guys, so again I have now another diagram here. Image formed by concave spherical mirror. See, the difference is we have the same mirror, okay, same mirror we had before, but now it's forming the image somewhere. Look at it, it's forming bigger image. So look at this. Why is this case? It has to really do with this. If it is the same, concave spherical mirror, the thing we change in this is the location of the object. So see, earlier we had location. This image was, this object was light somewhere around here, right? Before the center of a curvature, and then we got some diminished image here. Now this object lies very close to, it lies in between focal point and mirror itself. So this is our object here, okay? And then by the time we get the image, then it forms really big image, it forms behind the mirror, and then this type of image, look at this, I don't have an actual line here, I have only dot dot dot, this type of image where light appears to meet. They don't actually, form the image by meeting the intersection of light, but it forms by the appearance of light interacting at that point, intersecting at that point. This type of image is called virtual image, okay? So real image and virtual image. Real image has to do with the formation of the image by actually the intersection of the light, okay? Virtual image, it has to do only with the appearance, not actually happening there, okay? So that's the difference. So this image, which is like this, if object was in this position, the image formed is also in the same position, same direction, same. So this is called upright, it's a virtual. Since the size is bigger, now it's called magnified, okay? So now it looks kind of cluttered here. I'm not cluttered, like it looks like really complicated, but it's really geometry, okay? Basically it's just making a good drawing. If we don't do it well, if we don't do as precisely as we can, you see earlier even my diagram didn't work, right? So we have to do as much as we can. We want to draw it as precisely as we can, okay? So let's try to draw it here. Let's try this together. Or you guys wait and see, maybe, who knows, maybe if I, somehow if my diagram doesn't work, I may have to do it so you guys don't work. You guys just see it here, and then I'll let you guys, give you guys some time to draw it, okay? So let's look at it. So let's try. Okay, so since I was talking, just a moment. Let us use this. This one is going to make the board dirtier. So let's try this, okay? So this is our concave spherical mirror, same mirror, okay? Now first thing you want to do is, make a center of this mirror somewhere, maybe, yeah, make it far away so we can see the diagram more clearly. This is, let's call this as our center, and optical axis should pass through that center, right? This center, okay? That doesn't look, wait, let me, I like to draw it as precisely as I can. Sometimes it does not happen. So this looks more like a center. Let's see, this is our center. Let's take the light optical axis here. So this could be our optical axis again, looking and going this way, okay? Now let's say this is our focal point F here, alright? Now where is our object? Object is in between mirror and then our focal point, okay? So let's make this object here, it's gonna get messy here. Object in between focal point and a mirror. Now first thing is we want to draw a parallel ray, right? So how does the parallel ray work is this. Parallel ray, if you draw here, this is a focal point, it has to pass through the focus, right? So it does need to touch this guy though, object. So let's draw this. So this ray that passed through the focal point also touches the tip of the object, goes here to the mirror. Now it's entering this way, okay, and then it doesn't go here, but it kind of goes, we can make it like this, right, dot dot dot, but then it comes back, it reflects parallel to the optical axis like this, okay. So it is coming back parallel to the optical axis. Now we want to draw central ray, okay. So central ray actually goes from, again, touches the tip of the image, important, right? And then, but then when it goes to the, gets to the vortex of the mirror, it's going to reflect back at equal angle, okay. So if we look at here in this diagram, this would be our orange color, right? This would be our this would be our central ray, okay. So let's try to draw a central ray. Okay, let us see. Drawing central ray like this, right? And then now it is going right like that, and then it's going to reflect back at equal angle, okay. But then now what we could do is we can just, you know, project this guy here. Wait a minute, I made a mistake, guys. Here the mistake is this, I want to tell you guys, please don't make it. The incident ray, you don't make this dot dot line for incident ray, you make it for the reflected ray, okay. So here earlier I just draw it and then I am not supposed to do that. I make it this one, and then when this is reflected, now for that reflected ray you trace this apparent light path, okay. So here also this light actually goes here, it touches the vortex, it reflects back, but you don't do this dot 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 for this incident ray, okay. You do it for reflected one. So now this one I can draw this intersection here, okay, like this. So I have basically two rays. You can draw more rays here, like really two rays will give us a tip of the tip of the image. I can just finish with this, or you can add more, more light, like more path, just like here, right? You see here there is also focal ray here passing through the focal point, and then it's also coming back here. You also see green light here, right? This is a radial ray that's just going there. If you guys want, we can also draw a radial ray here, but then it's going to go all the way up there, okay. So I'm not going to draw the radial ray here. It's kind of, look at this, it gets messy, but as long as you have a two light path that are intersecting, you should be able to figure out the tip. This is going to be our tip in this case, so I can just draw this guy here. So look at this, right? This is the image, right? Let's call height of this object, let's call h. Let's call height of this image as h dash, okay? So basically this h dash, or the height of the image, is a lot bigger than the original object, okay. So what we see is, we see really magnified image. It's upright, and this is a virtual. Why it is a virtual? Why do we call it a virtual image? Because it is formed by the, it appears that the light intersect here and the image is formed, but actually light rays, they don't, in reality they don't actually intersect there, okay. So light actually, they are reflected back. Alright, so that is about a concave spherical mirror. So you can note that the thing we changed in this diagram and the previous one is just the location of the object. Because we changed the location of the object, that's why now we have a different image, okay, a different image is formed. So this is an important thing to note. Please take a moment, draw your diagram, take some time to draw it as good as you can, okay. Okay guys, so let's look at this another type of spherical mirror. Okay, so I also mentioned to you guys a few minutes ago that there is also another mirror, spherical mirror, that's called convex spherical mirror. The first one we looked at is concave spherical mirror. This is a convex spherical mirror, okay? Again, this spherical mirror is also formed by taking a portion of the sphere, okay? Spherical mirror, basically. So now, how do we make it? So again, the same process. This part I'm not gonna do it. You guys, take time and draw it, okay, for this part. So convex spherical mirror, if we take just a portion, the other portion, earlier we had this part, right? That was our concave mirror. Now this part is going to be if we take this part of the spherical mirror, then that will give us a convex spherical mirror, okay? So basically, I showed you guys this. What is it? Where is the? So idea is something like this, right? I mean, of course, this is not perfectly spherical, but like one side would be like one side is like this, the other side is bulging like this, right? Bulging side, and the other side was curved side, right? So you see, that's what we are drawing. Okay, so please take a moment to draw this. Make sure you also draw this radius, okay? R, radius of curvature. Okay, so now you also want to draw a focal point in the center of curvature. This thing I think I didn't mention earlier. So this focal point is basically half of this radius, okay, over there. So center of curvature, that's like your R, right? So if you take about like half, you can get the focal point there. Focal point, okay? So again, please make a dot focal point as well as a center of curvature. Okay, so now here convex spherical mirror. So I want you guys to draw this, but first look at this, okay, and then you can draw it. So convex spherical mirror, same diagram you had, you can use the same or you can draw another one. So now if we put an image, if we put an object here, okay, this object we have, now we again have to draw, you can use like main 4 principal rays, or if you can get the diagram with the 2 rays, that's also fine, but 4 rays will definitely give you a diagram, okay, give you a position or location of the image, okay. So let's look at it. We have this object here. Now let's look at the parallel ray, right? So the parallel ray is the red color right here. It goes like this, it touches the mirror. Since it's a parallel, it has to reflect, okay? Now when it reflects, it has to reflect, right, this, but then now for the reflected light we can project behind the mirror and make this dash 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 line that must pass through the focal point here, okay? So please make this one in your diagram. Okay, now let's look at central ray. Okay, so here green color is a central ray, right? So central ray, property of central ray is it passes through the center of a curvature, right? And then it does not, it passes to the center of the mirror, but that's what it means. And then it reflects through the same path, basically. So here, if we make a line from tip of this image, it goes through the green line path, right here. Once it touches to the mirror, it's actually already reflected back through the same path. Okay. Now for that reflected image, we can make a projection behind the mirror. So we draw a dot, 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 dot line that passes through the center of a curvature here. Okay. So please draw that one. And we also have a central ray. Okay, so sorry, earlier I should have green. This is a radial ray, not the central ray. I mixed up the name. So green was the radial ray. This central ray goes like this, right? Look at this. It goes there. It reaches the vortex of the mirror, right? And then it reflects back at equal angle. Okay, so it is reflecting. Now for this reflected path from here to here, for this one you can draw a projection. Okay, so this dot, 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 dot behind. So after looking at this, we have only 3 rays here. Basically we see that our image is formed here. It's in between the mirror and the focal point here, right? And then it's tiny, right, which means it's minified or diminished, right? And it's also, it looks as, just this, it has the same posture, so basically it's upright, okay? But then it is virtual because it formed by the appearance of intersection of lights, okay? So this is a virtual image, okay? Alright guys, so make this, this central ray, and then make sure you get this image, okay? So let's call this height of this object height as this. Object height as h. Okay, I'm just writing equal, really meaning object height is represented by h. Image height, I'm just going to do this. It means the same thing as this guy here, okay? So I don't have to rewrite this. Image height as, let's call h dash. So in this case, h dash is smaller than h, okay? Now, let's call the distance, object distance. Distance equal to s. Now, what is this object distance? So basically, when we talk about this, these distances, we measure a distance from the plane of the mirror. How do we draw a plane? Plane is basically you draw a tangent to this, mirror, then that will be a plane of the mirror. So for example, you may be like wondering, what is that plane? I have this, if we had this, perfectly spherical here, at least on the side, if we were to, make it something like this, and then from your perspective now it is a tangent, right? It's only touching. So this plane is gonna be something like this. If I were to put a dot dot here, it's gonna go, it would be like this. And then it would be kind of like this, okay? So if we draw these distances from the plane of the mirror, okay? So let's call object distance S. In this case, the distance would be from this object here all the way to this point here, right? Because that's where we would draw a tangent. So that distance is our object distance. Let's also call image distance, find image distance. Let's represent it by S dash for image distance. Now the image is formed here, so the image distance would be again from the plane drawn here, tangent to the mirror, right? That would be the plane of the mirror. And then from here all the way to the position of the image, that will be our S dash, okay? S dash. Now there is something called thin mirror equation. What does this tells us is that